let's look at how we can solve equations that have variable exponents. And on these equations, we will be able to get the same base on both sides rather easily. We'll discover later on in this chapter what to do when that's not possible. But today, it will be possible. So, one thing you need to remember is your powers of some common numbers. You should recognize these powers of 2, 3, 4, 5, 6, 7, and the easiest ones of all, hopefully, 10. Those powers of 10 will be very handy later on in the chapter as well. So when we see these numbers, a number like 125, you should think, oh, that's a power of 5. Or when you see 16, that's a power of 4 or a power of 2. Or when you see the number 81, that's a power of 3, also a power of 9. So be sure you're able to recognize these powers that you've been dealing with for quite a while. Here's our first problem. The cube root of 32 equals 2 to the x power. So this is something new for us now. X is not down in here where it's always been for your math career. All of a sudden it's up in the exponent spot. We haven't had to solve for x in an exponent spot before. So here's the strategies we're going to follow. First, take care of any fractions or radicals. We don't want them when we're doing our work. So we want something to a power equals something to a power. It's okay if our power is a fraction or a negative number, but we don't want where you see Clifford or Shaun the sheep. We don't want radicals there. We don't want fractions there. And we've got one. We've got the cube root of 32. We'd rather have that written as an exponent. The cube root of 32, well, that's 32 to the 1/3 power. And then we have 2 to the x power. That's going to be okay. So our bases don't have any fractions and don't have any radicals. That's where we are now, and our next step is probably the most challenging step. Get the same bases on both sides of the equation. We don't have that right now. We have a 2 and a 32. But as we looked at earlier, we need to recognize what 32 is a power of and what 2 is a power of. Are they powers of the same number? And they are. They are both powers of 2. So we're going to rewrite them as powers of 2. Well, the 2 won't be very difficult. It already is a 2. But 32 is 2 to the 5th power. So no values have really changed here. This is still the value 32, but we're going to write it as 2 to the 5th power because the goal is to get the bases the same on both sides of the equation. Well, here's a power to a power scenario. We really have 2 to the 5/3 power equals 2 to the x power. We've got the bases the same on both sides of the equation. Our next step is to make a new equation by setting these exponents equal to each other. If 2 to some power equals 2 to some other power, well, these powers or exponents have got to be the same. So we're going to dump these 2's. We don't really need them. We were just using them. So now we can set the exponents equal to each other. 5/3 equals x. Lastly, we'll solve this new equation. Well, on this one, it's done. There's no more work for us. X equals 5/3. You could flip that around and write x on the left and 5/3 on the right. But we found it. If you want to check your work, go ahead. Plug in 5/3. 2 to the 5th power is 32. And the 1/3 power, that is the cube root of 32. That's what we have over here. Let's check out another one. We're going to solve 9 to the x plus 3 power equals 1/27. Our first step is to take care of fractions or radicals. Remember, we just want something to a power equals something to a power. And we're okay if the powers are fractions, we're okay if the powers are negative. But where Clifford and Shaun the sheep are, we don't want radicals, we don't want fractions. And we've got a fraction right here, 1/27. We want to write that in exponential form. Well, if we slide the 27 up, that makes it 27 to the -1 power. Now, it's something to a power equals something to a power. Our bases are not fractions and our bases are not radicals. That's what we want. Next, speaking of our bases, we want to get the bases on both sides of the equation to be the same. And we have to recognize, as we saw in that early slide, 9 and 27 are powers of the same number. And they're both powers of 3. We can rewrite them as powers of 3. 9 is 3 squared. 27 is 3 to the 3rd power. So, where there used to be a 9, there's now a 3 squared in parentheses. Where there used to be a 27, there's now a 3 cubed in parentheses. The values are the same on both sides, but they look different. 3 squared instead of 9, 3 cubed instead of 27. Well, it's power to a power on these exponents, so I'll have to distribute this 2 and multiply this 3 times the -1. 3 to the 2x plus 6 power equals 3 to the -3 power. Now we'll make a new equation by setting these exponents equal to each other. 3 to some power equals 3 to some other power. These exponents have got to be equal to each other. So we'll dump the 3's. We were just using them anyway, so we could set these exponents equal to each other. 2x plus 6 equals negative 3. And now we'll solve this new equation. Subtract 6 from both sides, divide by 2, x equals negative 9 halves. If you want to plug it in to see if it works, negative 9 halves plus 3, that would be negative 9 halves plus 6 halves is negative 3 halves. And the square root of 9 is 3. Cube it, and that's 27. And the negative part of the exponent sends it downstairs into the denominator. It does work out. Checking it is optional. If you've done all your math correct, you'll be okay. What if you don't see an exponent? So in this example, 3 to the negative x power equals 81. There's no exponent on the 81. But any number to the first power is itself. So if you don't see an exponent, the exponent is 1. So I can write the 81 as 81 to the first power. Now we have a base to a power equals a base to a power, and you're ready to continue solving this equation.